source code analysis is one of the powerful large language model application. In this video tutorial, we will see how we can chat with our own GitHub repository, just like we can chat with our own documents using the power of LangChain. Or you can say that we will do question answer over the code base or the GitHub repository to understand how it works. So here you can see the complete architecture. First, we have the source code. We will extract the complete source code. First, after extracting the source code, then we will split our source code into different chunks. Then we'll create embeddings for each of the text chunk. Then we'll save those embeddings in a vector store. And then we'll do a question answer with our stored data. So in this way it works. So here is the complete architecture. So the architecture is the similar as you can see when we do a question answer with our documents or multiple PDFs or with the CSV file. So we have created bunch of video tutorials already on how we can do question answer with our documents, CSV files, which include PDF files as well. So the architecture is same as that of the architecture. So we will just follow this architecture and then we will do a question answer over the code base to understand how it works. I will also there is a link, there is a LangChain documentation for this as well. So I will just add the link of that documentation in the description, so you can just check it as well. So here I have divided this complete tutorial into multiple steps. So we'll just go step by step and see how it works. So in the first step, I will install all the required packages. So here I will be using OpenAI model, plus I will be using ChromaDB as our vector store, plus we are using LangChain. So LangChain is just a framework that allows us to build large language model, and we use OpenAI models. We require the TikToker package as well. So I'm just installing all the required packages. As I want to just download or clone a GitHub repository, so in my Google Colab notebook, so I require the Git Python package as well. And in this tutorial, we are going to do a chat with this LangChain repository. You can see over here. So we will be doing chat with this LangChain repository, which you can find over here. So I will be just downloading this LangChain repository in my Google Colab notebook. So for this, we require the Git Python package. So here you can see I'm just importing all the required libraries from Git import repo. So to clone the GitHub repo in the Google Colab notebook, we require in repo package. Plus we have text editor. We are importing language from the text editor, and to load the files like extract the data from the complete, or you can say when if you want to extract all the code base from the GitHub repo and just store that code in a variable, we require generic loader so that we can just load our .py file and extract the data from those .py files. So next we have we are importing language parser. So in the language parser, we are just importing language parser from the langchain.document-loader.parser. So why we require language parser library? So in the language parser, we'll pass the extension of the programming language we are working with. So a LangChain repository is basically based on Python. So if we just check over this, so it's all based on Python. So we will be using extension .python in this case. Okay. So in the language parser, we'll pass the extension of the programming language we are working with. Here we are working with Python programming language. So we will add Python. If we are working with Java, C++, or any other programming language, we will add that extension as well. Then we have a recursive vector text editor. So after extracting all the code from the GitHub repository, or after extracting all the data from the GitHub repository, we will split the extracted data or code into small chunks, because OpenAI model or any other language model has an input token limit. Like OpenAI model has an input token limit of, like GPT-4 model, OpenAI GPT 3.5 model has an input token limit of 4096 token, which is one token is equal to 4 English characters, which is around 16,000 English characters. So we cannot pass more than 16,000 English characters at the input of our OpenAI model. So when we extract all the code from this GitHub repository of LangChain, so it can be more than 16,000 characters. So we cannot pass that data directly to the large language model. So we need to split that data into small chunks. So for this, we require recursive character text splitter and import OS, and OS package is required because we want to set up the environment of OpenAI. And if we want to exit from the code, we can use sys package as well. So here I'm just downloading embeddings from OpenAI embeddings. And here I'm importing Chroma as our vector database. And here I'm using chat OpenAI so that I can chat with my GitHub code repository. Then we have conversation summary memory. So to add the memory component to our in our question answer chain, we can use conversation summary memory. So to add memory component in our conversation in our QA chain, we can use conversation summary memory. It will look at the historical conversation first. So then it will compute the summary and it can add it to the subsequent conversation as well. So then we require conversation retrieval chain. So conversation retrieval chain is being built on retrieval QA chain. So the difference between conversation retrieval chain and retrieval QA chain is that in conversation retrieval chain, we can add a memory component as well. So we can keep track of our conversation chat history. So I'm just creating a directory by the name test repo over here. Okay. So in that test repo directory over here, I will just clone the GitHub repo of LangChain and just save in this part. Okay, so now you will see in just a minute. So if you can see this test repo in this, we have just cloned the complete LangChain repository from GitHub. So now I will just go to libraries and then go to LangChain, and we will be loading all the .py files which we have over here. Okay, or you can say that we will be we will go through each .py files, because you can see that .py. So we will go through each .py files and we'll extract the data from those .py files. So in the language parser, we have language Python. I already told you we are working with Python programming language as well. And parser threshold is 500. And .py files we are dealing with, and it will just go to each .py files in this LangChain over here, and it will extract the data. And the data will be saved in the documents variable, which we have over here. Okay. So now if we just see over here, we have like from future annotations, from typing, import. So here we are just importing the packages. So we have extracted all the code. So I've just, there are 1,428 documents. I'm just showing you how the first document looks like. Okay, so now we just want to split this extracted code into small chunks, and each text chunk will have maximum 2,000 English characters, and there will be an overlap of 200 English characters between each chunk. So we have now in total of 4,395 chunks. So now we are just creating an environment over here and just passing OpenAI API key so that I can use OpenAI chat model as well as I can use OpenAI embeddings as well. So OpenAI models are not free. They have some costs associated. So currently we are using OpenAI model. In the next tutorial, I will show you how you can do this with a Llama 2 model, which is an open source model and it's completely free to use. Plus we will be using Hugging Face embeddings in the next lecture as well. So now we are just setting up Chroma as our vector database. So now we have downloaded OpenAI embeddings and we have split the text into small chunks. So now we will create embeddings for each of the text chunks, and then we will save those embeddings in our Chroma vector database. Okay. So now we will just split each of. So now we will we will create embeddings for each of the text chunks. So you can see that here I've just passed text. So these are basically text chunks, and now we are just pass embeddings. So these are OpenAI embeddings. And now we will creating embeddings for each of the text chunks, and then we are saving those embeddings in our Chroma vector database. So in Chroma vector database, our embeddings are basically saved locally. But if you use Pinecone, it saves the embeddings in the cloud. So you can see over here, our embeddings are being saved locally over here. So if you use Pinecone, it will save the embeddings on the cloud and anyone can access those embeddings. But using Chroma, we can we can save the embedding locally. So now here I'm just creating an OpenAI model wrapper. I'm just using GPT-4 model over here. Okay. So here you can see the details, like we are using GPT-4 model. We have default temperature set to 0.7 over here. Okay, now we are just initializing conversation summary memory so that we can keep track of the conversation hit free. And here we are just creating a conversation retrieval chain from LLM. We are using Chroma as our vector database. You can see over here. And we are just using search type as MMR over here. MMR stands for maximum marginal relevance. We have other search type as well, like similarity search, but here we are using search type as maximum marginal relevance. The reason for using search type MMR is that we don't want all the chunks to be retrieved from the same document. So like you can see over here, we have set k is equal to 8. So when the user asks a question, we will go through the embeddings where we have saved all the data. So we will generate 8 different answers for the question that the user has asked, and then we'll pass 8 those different answers to our large language model, which is chat OpenAI model, and the chat OpenAI model will generate a natural response from these 8 different answers. So I don't want all these 8 different answers from the same document. So like from a single Python file, I don't want all the 8 answers from the single Python file. I want all 8 answers from each different Python file. So I want 8 answers from 8 different Python files. So get answers from 8 different Python files, we can define search type as maximum marginal relevance. There are also other search type like similarity search, but in this case, we will use maximum marginal relevance as our search type because I want an answer for a question from 8 different documents, not from a single document, or you can say it's by document ID means .py file. Okay. So let's run this first. So now I will just ask a question and now I will just get a response over here. So let's see what answer do we get. So now it might take few more seconds before we get the answer. Okay, so now I have just asked how I can initialize React agent. So we have the chat history component over here as well. Plus, I believe we have source document. So no, source document is not. But we have the answer over here is the React agent is initialized through the following step. Define the output parser. The output parser is the React output parser by default. Other is set the agent type, define the prompt creation method, validate the tools, set observation prefix, set the stop it. So you can see that it has given me all the steps. So the second question which I can ask is what is class hierarchy? And let's see what is class hierarchy. And let's see what answer do we get over here. So the class hierarchy for memories, base memory, base chat memory, memory, and here you can see the class hierarchy for chat memory is message history is, and you can see over here. So in this way, we can chat with our own GitHub repository or any GitHub repository available publicly using the power of LangChain and OpenAI. So here we have done source code analysis. We have asked some question from our source code and we are just getting an answer. So source code is one of the powerful large language model application. And here we have seen that how we can chat with over the code base to understand how it works. So we have done question answer over the code base to understand how it works. And that's all from this tutorial. Thank you for watching.